Greetings everyone. Today we're going to explore circles. We're going to talk about graphing and writing them, and having your Conics foldable available will be very helpful. Since this is the beginning of our conic sections unit, let's just go over what is a conic section. When you take two cones and put them point to point, if you were to slice that solid, you would create conic sections. So for example, if I had a perfect horizontal slice, as you can see here, I could create different sizes of circles. If I slightly slanted that slice, I would have an ellipse. If I sliced even more slanted through the base of the cone, then I would have a parabola. And if I sliced a perfect vertical piece, I would have what's going to look like two parabolas, but because of their symmetry and relationship, we call that a hyperbola. We are going to explore these four conic sections throughout this unit. Let's start with the circle. Quick review, this is from geometry class, so you're very familiar with these. First of all, we have the center. We have the radius. A couple of other things to consider. We know that the distance across is called the diameter. If you know the diameter, you know the radius, and vice versa. A couple other things you might need to know in order to be prepared for this section is a quick review of your geometry formulas. Remember that the area of a circle is pi r squared. To find the circumference of a circle, you're going to use the formula 2 pi r. Now, sometimes you'll be given any one of these variables and you'll need to solve for the other, so be prepared. Let's talk about the standard form of a circle. You've got a place to fill this in your notes. What you'll notice is the formula has a subtraction sign in the parentheses. That's very similar to any horizontal shift in our previous functions, meaning if it says x minus 7, we use positive 7. You'll notice how both the x and y values are squared. That's what creates that circle shape. And it's always equal to the radius squared. So if my radius is 5, I need to make sure it writes 25. Or if it says equal to 100, then I know my radius is 10. Let's look at some examples. Our first example in our notes looks like this. You'll notice there are no shifts horizontally or vertically in the parentheses. So because of that, we're going to start off a little easier and say our center is at 0, 0. Now in the formula, it says that we are always equal to r squared. Well, my answer says 12, so I have a little bit of work to do here. I need to say that r squared equals 12. In order to solve, I have to square root both sides. And square root of 12 breaks down into 4 and 3, therefore 2 square roots of 3. If you need more support with reducing radicals, make sure to check out that lesson video. My radius is 2 square root of 3. Now to draw that radius, think about this 12. What's the closest perfect square to 12? I'm thinking of 16. We're between 9 and 16, which means we're between 3 and 4. So we can't be exact, but you're going to go 3 and a little bit, or it's going to look like 3.5 a lot because of our graphs and how we show our points. You're just going to be in between the 3 and the 4. Now, try your best to connect those dots to create your circle. Let's take a look at the next example. We want to start applying shifts to our center point. If my x says positive 2, I write negative 2. If my y says positive 3, I write negative 3. So it's true for the x and the y. Let's draw that center point. It says that r squared is 36, so a nice clean 6 for our radius. So we're going to go 6 north, 6 east, 6 south, and 6 west. and then connect your dots to the best of your ability. No judging here because I'm using my tablet, so it's going to be all kinds of interesting curves. Let's take a look at the next one. This example is just here to show you that you can still have a value of 0 and an integer value together. So 0, 1, we're on the y-axis here. That makes sense. We have r squared equal to 64, therefore r is 8. So we're going to go 8 in each direction. And if you are using a specific Conics foldable, you likely will have a graph of 10 by 10, so you can kind of use that to your advantage there. Let's connect our dots, create our circle. Whoops, way off there. We'll just go with that. All right, let's take a look at this next one. Center point, pretty easy. We've got a 4, -1. What's going to be a little more challenging here is that radius piece again. R squared is 20. R squared is 20. If I square root both sides, I have the square root of 20, which breaks down to 4, 5. So my radius is 2 square roots of 5. Again, I'm not going to spend a lot of time on reducing radicals. That is knowledge that is needed from geometry, but I do have videos for it as well. The closest perfect square, think about square root of 20. Square root of 20 is between which two perfect squares? 25 and 16, right? So because it's between those, we want to go between 4 and 5. So 1, 2, 3, 4, 5. Now, the reason why I'm showing you that without a calculator is because you are going to have assessments where you are not allowed a calculator. And so you have to understand the about how much is that square root. All right, let's work on writing these circles. When given a graph, it's actually pretty easy. Now, my first suggestion is to memorize the general layout of a circle, meaning what I have written here, right? Treat it like a fill in the blank. You do need to have this memorized. The first thing I'm going to acknowledge is my center point is at 5, 1. So I'm going to write -5, -1. I'm then just going to straight count my radius. 1, 2, 3, 4. But we put r squared, so we've got 16. Now, the graph ones were pretty easy, right? We can straight count. So one of the things that I'm going to encourage is that if you're getting stuck on any of these, consider drawing a picture. If you can visualize it, it might help you out. So your marker board might be of help as well. Let's start off with this one. This one we're told our center point and we're told our radius. And so we can jump straight into writing this one. Again, memorize that general layout. Sorry, my handwriting's off today. Oh my goodness. We've got an X and we've got a Y. Let's fill it in. I'm going to fill in a -9 and a +4. Now we got to do a little bit of work here. It says that my radius is 2 squared of 7. I need to square that for my answer. Ooh, remember, squared means times itself. If I write it this way, does that make more sense? 2 times 2 is 4. Square root of 7 times square root of 7 is square root of 49. Square root of 49 is 7. 4 times 7, 28. Another way to look at it, let me just provide another option. That was kind of the longest option there, but let me show you another way to think about it. Because this is product of a power, you can distribute the squared onto both pieces of the product. So I get a 4 times a 7, which can also get me to the 28. Let's take a look at this one. We're going to write the equation given the center at -1, 7 and a point on the circle. All right, here's where that marker board is going to be helpful. I am just going to do a generic graph sketch, but use your marker board. If I do a generic sketch, I need the first and a little bit of the second quadrant. My center is at -1, 7. Let's say this is -1, 7. It doesn't have to be exact. And I'm just going to make that another color to show that's my center. And a point on the circle is at 9, 10. 9, 10. I'm just doing this to visualize it. So that means my circle is some sort of big circle like this, right? All right. I'm going to encourage again that you prep your equation because you do need to have that memorized. So the first thing we can do is we can fill in that center. Super easy, right? No concerns there. It's just that I need to find my radius. My radius is a slanted distance. You have several options. First option, distance formula. If you memorize that from geometry, then use that prior knowledge. Second option, create a right triangle. If I create a right triangle, the distance between my x's, so count -1 to 9, is a distance of 10. Count your y distance. The change between my y's is 3. We could do Pythagorean theorem. A squared plus b squared equals c squared. That gets me 100 plus 9 equals c squared. 109 equals c squared. So that means this length is the square root of 109. Now, I don't need the square root, you guys. We want this to be r squared. We want just that 109 that we found. We want the value squared. So 109 is our answer. All right, let's try out this one. There's a little more space for this one. We're going to need a little bit more work on this one. Consider your marker board, right? Or some type of sketch, some type of graph to help you visualize it. I'm going to draw this sort of generic graph. I'm going to use the second and the third quadrant. I can see -4, 7 is right here. That is an end point, so -4, 7. And my other point is -8, -17. I'm way down here. -8, -17. Those are the ends of my diameter, which means my radius is determined by my center point, which is somewhere in there, right? So here's my center. So I'm going to find my center first. Okay, let's prep our answer. Something squared plus something squared equals radius squared. I am going to reference your geometry understanding. You could use the midpoint formula. Listen, if I have a distance of x's from -4 to -8, what's the middle value on a number line between -4 and -8? Or find the average of your x's. In the end, it's -6 is the middle, right? So I'm going to write plus 6. My y value from -17 to 7. That is a distance of 24. So if I cut 24 in half, that's a distance of 12. -17 plus 12 gets me a -5. Let's see if that works. That means -5 to 7 is 12. -17 to -5 is 12. That means my y value, I write plus 5. Okay? If you need to look up, if you don't like the idea of counting, use your midpoint formula, but I'm going to leave that up to you to remember or look that up. Let's talk about our radius. We need to find our radius. So I'm going to approach it. Again, you could use distance formula. I'm going to approach it as a right triangle. Okay? And so if I count the distance between my x's from -6 to -4, that's a distance of 2. If I count from -5 to 7, we already said that that was 12. And I'm going to take care of Pythagorean theorem. A squared plus b squared equals c squared. That's going to get me a 4 plus 144 equals c squared. So 148. And I don't need to square root it to find the actual distance because I want the radius squared. Okay. Again, there are other formulas, other ways, but you do have to be persistent in sort of figuring out what's the best way for you to understand this. All right, as always, make sure to check out Google Classroom to see what you have to do to go along with this lesson. Let me know if you have any questions. Seek out help in our resource room. And until next time, have a good one.